I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Let me thank all the viewers and subscribers for watching my videos and taking keen interest. I receive excellent comments and very useful suggestions. Many times, students post good questions to be answered. Here is one of the questions from our subscriber Melissa. Melissa, thanks a lot for posting this question. Many students at present are working on probability distribution, and expected value. I hope with this example they will understand the basic concept and will be able to solve even the most difficult question in their test paper, which will be on statistics or data management dealing with probability. So, once again, thanks, Melissa. I'll get into the solution of this problem in details so that most of my students get the benefit out of it. So let's see what the question is. There are 10 marbles in a bag, some green and some blue. There are more blue marbles than green marbles. If two marbles are chosen randomly from the bag, the probability they have the same color is 24 by 45. Part A is find number of blue marbles in the bag. Part B, find most likely number of blue marbles when three marbles are picked randomly. And C is find the expected number of blue marbles when three marbles are picked randomly. Very good example. Part A deals with the probability, and that too we are picking up two same marbles, correct? Part B is more on the probability distribution. We'll see how do we define a random variable and answer this question. And then part C is on expected value of picking up blue. Isn't that interesting? So let's get into the solution of this question. Some of you definitely can pause the video and answer the question. So here is the thought about the solution. There are 10 marbles in the bag, some green, some blue. So let's say the blue marbles are X, right? So let's say blue are X and green will be how many? Well, the green will be 10 minus X since the total is 10. Now we are given a condition that X is greater than 10 minus X, correct? How does that help you? Well, that tells you that what could be the number of blue marbles. Let's bring X together. So we have 2X is greater than 10, and then we'll divide by 2 both sides and we get X is greater than 5. So for sure, the number of blue marbles should be greater than 5. So we get one condition that the blue marbles are greater than 5, correct? Let's keep this in mind while we answer the question. And our second point, which is very important to look into, is that if two marbles are chosen randomly from the bag, the probability they have the same color is 24 by 45. What does that mean? So we are given the probability of two same color. That means they could be both green or both blue. You get the idea. So they could be, we could bring two blues or two green. You get the idea. So you have to look for both. And that probability is given to us as 24 over 45. Perfect. Now keeping that in view, let's continue with our solution. And so we say that probability of two blue or two green is what? Well, for getting two blue, we are saying blue is x and green is 10 minus x. So out of x, we get 2, right? Divided by the total is 10 C2 plus out of 10 minus x, we get 2. That is for green, and then total is 10. So denominator is we have 10C2 choices. And this is given to us as 24 over 45. Is that clear to you? That is how we should be solving. Now, you should remember the formula of what is NCR equals to. Well, it is n factorial over n minus r factorial times r factorial. Correct? That is the formula. So if I have to calculate xc2, for example, then xc2 will be x factorial over x minus 2 factorial times 2 factorial. Correct? Let's try to see how do we solve it. Factorial means product of these numbers, correct? So product of these numbers will be like x times x minus 1 times x minus 2 times so on. So that I could write as a factorial here. So x minus 2 factorial in the denominator will cancel. 2 factorial basically is 2 times 1, correct? So what do we see here? We see that we can simplify this expression. And so what we really get is x times x minus 1 divided by 2 in the numerator. You get the idea. xc2 will be this. Similarly, x 10 minus xc2 will be basically equal to 10 minus x times, 10 minus, 10 minus x minus, because there's less space, let me write closer. So I'll write like this, 10 minus xc2, right? 10 minus 10 minus xc2, right? So I'm just squeezing it in. So we'll have this as 10 minus x times 9 minus x divided by 2. Is that clear to you? And what is 10c2? Well, 10c2 will be 10 times 9 divided by 2. Is that clear to you? So these are the numbers which we have to fit in here. So I'm writing them what we simplify. And of course, divided by 10 and divided by 10. Do you see? That is in our denominator, and the numerators have those 2's. They will cancel away. And therefore, what we get really here is, so I'm writing a simplified expression so that it makes sense to you, right? Well, let me write the total thing. X times x minus 1 divided by 2 divided by 10 times 9 divided by 2 plus 10 times 10 minus x times 9 minus x divided by 2 over 10 times 9 divided by 2. You could write like this, correct? Okay. Now what I'm saying is that these 2's will cancel. Is that okay? So we'll have a simpler expression to write. So let's continue with this solution now. Probability is given to us as 24 over 45. And that should be equal to x times x minus 1 over 10 times 9 is 90 plus 10 minus x times 9 minus x divided by 90. Is that clear to you? Now we can multiply all the terms by 90. So if I do that, I get 24 times 90 over 45. Is that okay? And here also, I am getting everything multiplied by 90. Think like this. Okay? So when you do that, 45 goes 2 times with 90, and therefore we get here 48, right? Equals to x times x minus 1 plus 10 minus x times 9 minus x. Does it make sense to you? So we get this equation to solve. Well, let's take it to the next page and solve it. We could write this as 48 equals to x squared minus x plus 10 times 9 is 90 minus 10x, and then we have minus 9x, minus and minus becomes plus x squared. Let me simplify here, and then we'll take it to the next page to solve. X squared plus x squared is 2x squared, and then we have minus x minus 10x minus 9x, which gives us minus 20x. The constant being plus 90 So 48 is equal to all that. We will now simplify this. We can write this as equal to 0 equals to 2x square, bringing 48 to this side, minus 10x minus 20x, plus 90 minus 48, which is plus 2, and 9, 8 take away, this is 42, equals to 0. So 0 equals to 2x square minus 20 plus 42. We'll take it on the next page and then solve further. So what we get here is 0 equals to, uh, let me see what it was again, 2x square minus 20 plus 42. We can take 2 common. So we get x square minus 10x plus 21. Now this can be factored. Product 7 times 3 will give us minus 10 if both are negative. So we can write this as x minus 7 times x minus 3. So that gives you two values. One is x equals to 7. The other one is x equals to 3. Now we know x should be more than 5, and so this is not valid. So this is valid, correct? As we know that x has to be greater than 5. There are more blue marbles than the green marbles. So find the number of blue marbles. We get our answer. Blue marbles is basically equal to 7, correct? And we know these are the blue ones, and the green are 10 minus 7, which is equal to 3. Perfect. Now let's do part B. Well, here is the complete solution of what I just shared with you. So there's some typing error here. So let the blue marbles be x, green will be 10 minus x, and since blue is more than green, we'll solve this inequality to get x greater than 5. We want the same color, that means this is actually 45, not 25, right? Typing error. So we have xc2 over 20 over 10c2, the probability of getting the two blue marbles, and 10 minus xc2 over 10c2 for the two green marbles, and that is given to us as 24 over 45. Now we can simplify this, and when we simplify, we get x times x minus 1 over 10 times 9, x minus 10, 10 minus x times 5, 9 minus x over 10 times 9 gives us 24 over 45. And now if we cross multiply, multiplying everything by 90, that denominator goes away. We get 48 here. And now we can open the bracket, simplify, factor, and then finally we get the value of x as 7, correct? Okay, so that's a neat and clean solution for you. Here is part B. Find most likely number of blue marbles when 3 marbles are picked randomly. Probability distribution, that is correct. Now see, if you are picking up 3, then how many blue marbles can you get? So we'll define a random variable. X, which is number of blue marbles. So what could be the value of x? Well, we may not get any. We get 1, 2, or 3. So these are the 4 things which can happen when you pick 3 marbles, right? When 3 marbles are picked randomly, you may get, you may not get, right? And if you get, they could be 1, 2, or 3. So that is what we need to figure out. What is the probability of getting, not getting any? for getting 1, for getting 2, for getting 3. So for each, we will now find the probability, right? So we'll find probability for each. Now for not getting any blue, this is for getting blue. That means all the 3 were green, right? So we know the value of x. This is the number of this x is basically the total number of blue marbles, right? Is 7, right? And green are, we just found that, correct? 3. So total is 10, right? It adds to 10. So when we say 0, 0 blue, it means all were green. So out of those 7, you chose nothing, correct? And as far as the green is concerned, we chose all 3. That's why we didn't get any blue. You get the idea, right? So that is what it is. And their probability being that they have been 3 have been picked from 10, correct? So that is what we get for 0. So that's the probability for getting no blue marble. You get the idea, right? Similarly, for one blue marble, what do we get? The probability will be 7 choose out of 7 you choose 1 and out of 3 you choose 2, correct? And the probability total number of options is 10 choose 3. You get the idea, right? And with 2, it is 7 choose 2 and 3 choose 1 over 10C3. And for 3, all were blue, correct? So none was green. So that becomes the probability for 0, 1, 2, and 3. You get the idea, correct? So we could write this as probability of choosing none of these, one of these, two of these, three of these, respectively, as shown here. Now you can calculate this value, correct? Use calculator and calculate this value, correct? So let me take a calculator to calculate this value. Well, 10C3 is what? 10 times. So what is 10C3? 10C3 is basically 10 times 9 times 8 divided by 3 times 2 times 1, right? So that is 10C3. You can calculate this answer. 3 times 3, this goes 4 times. So you get 120, right? 12 times 10. This is 120. So the denominator being 120 for each. Correct. Now, when we say 4, 7C0 and 3C3, so that means 1 time 1, right? So this is 1 time 1. 7C1 is 7 and 3C2 is what? 3C2 means 3 times 2 and 2 times 1. So that gives you the answer as 3. So 21. 7C2 means what? 7C2 means 7 times 6 over 2 times 1, right? So that gives you 321 times 3 choose 1 is 3. So we'll multiply these. 7 choose 3. Well, basically means, let me calculate here. 7 choose 3 means 7 times 6 times 5. And this is 3 times 2 times 1. 3 times 2 is 6. So we get 35 here. 7 times 5 is 35. And 3 choose nothing means 1. Correct? So that is what we get. So now we can write down their probabilities as 1 over 120, and this is 21 over 120, and that is 63 over 120, and this is 35 over 120. Is that clear to you, right? So I hope this calculation is clear. So this is the value for, you can write this as x for 0, right? This is x for 1, this is x for 2, and this is for x3, right? So these are their probabilities. So that's what we call probability distribution. So probability of getting no blue is 1 out of 120. Probability of getting just one blue out of the 3 from this set of 10 is 21 over 120. For 2 it is 63 over 120, and for all 3 is 35 over 120. Is that clear to you? So that is how we have answered this question. Find most likely number of blue marbles when three marbles are chosen. So that is what it is, correct? You can always add this up now and then you get your result as what? So denominator is 120 and choosing one of these, you can add the numerators. We have 120 here. We get 1 plus 21 plus 63 plus 35. Correct? Okay, let's move on to part C now. Here is the solution as I was discussing with you. So basically, the probability for each is for no blue, for 1, for 2, and for 3 is 1 over 20, 21 over 120, for 63 over 120, and 35 over 120. I really did not simplify them further since it helps to keep them like this and to understand them better. So I hope till now things are absolutely clear. Now let's look into part C, which is find the expected number of blue marbles when three marbles are picked randomly, right? So out of three, how many do you expect as blue, right? Definitely they are more than 50%, so it has to be, out of three, more than 1.5 to give you a rough idea, right? How do we calculate this? So we just found that probability for getting no blue is 1 out of 120 and for getting 1 is 21 over 120. For getting 2 it is 63 over 120 and for 3 it is 35 over 120. So we'll add them up, right? So we'll find what is the probability for, so we'll multiply the xi with pxi where I in this case goes from 0 to 3, correct? So basically you multiply this. So 0 times 1 over 120 plus 1 time 21 over 120, correct? And this will be 2 times 63 over 120 and there will be 3 times 35 over 120. Is that clear to you? So that is what you do. So you can just add this up. And of course, we have 120 in the denominator. This is 0 plus 21 plus 2 times this is what? 6, 126 plus 3 times. 3 times 5 is 15, 1, 9 and 1, 10. 105 over 120. So you can add this. So when you add, you get what? 6 and 6, 12, 2, 1. So 1, 3, 4, 5. And then you have 1 and 1, 2. 252 over 120. Do you get this? So that becomes the probability which you see slightly more than 2, right? Slightly more than 2. So you can divide and get your results, right? So I'll divide by 4, for example. I don't have a calculator at present, so 4 I'm dividing by. So 4 times 6 is 24, so 63 over 30, right? They can be divided by 3 also. Okay, so they get 10 and 3 is 21, right? So we get 2.1. So 21 over 10, which is 2.1, right? So that is expected result. So if you pick up 3, then getting how many blues? Slightly more than 2, right? Definitely you'll get 2 blue. That is what we are saying as per this particular experiment, right? So that is how we can actually do it. Here is the solution as such, as we discussed. Now I hope it is absolutely clear to you. So what we are doing is we are picking 3 marbles and number of blue marbles could be 0, 1, 2 or 3. So for each we have found the probability distribution which is 1 over 120, 21 over 120, 63 over 120 and 35 over 120. Expected value is the product of these two. And when you multiply them, you add them up and get the expected value. And therefore, the expected value, as we just discussed, is 21 over 10. Do you see that? So this was an excellent example which gives you a fairly good idea about how do we solve questions which are related to probability, probability distribution, and expected value. I hope you find it useful and informative. Very much thanks to Melissa for sharing this question once again. Thank you all for watching. Keep posting your questions and enjoy my videos. Thank you and have a great day.